Well, hello, and welcome back. I'm AJ O'Neill. This is Beyond Code Live, and we are here to talk about const, let, and var. This is kind of an intermediate JavaScript concept, and the reason I say that it's intermediate is that there's a lot of nuance, and you have to be somewhat familiar with how JavaScript works in general and how some other programming languages work in general. So I'm AJ O'Neill. If you want to follow the content that's like this, that's @_beyond_code. And if you want to follow in on the live streams, which may be what you're watching this on now, and be able to comment and interact and get an invite to the Discord and all that, that's twitch.tv/CoolAJ6. With that out of the way, let's jump right in. And by the way, hello to the regulars, and thank you for joining in. Feel free to ask questions and comment, whatnot. All right, so first thing I'm going to do is refresh this, because I have updated it since, there we go. So now I put the little in small in JavaScript, just to be clear, because they do exist in other languages. So that was in alphabetical order. And this is the order in which we are going to speak about them. So I'm AJ O'Neill, and I hate const. So we'll get to that in a bit. So var, first let's talk about var. Var has been in JavaScript since the beginning, and it is incredibly simple and incredibly consistent. It has exactly one rule, which is variables declared with var are scoped to the whole function that contains them recursively. Okay, and you'll see examples of that. There are no exceptions to this rule. This is a perfect rule. It is perfectly consistent. It is a little unusual, but it's perfectly consistent, period. All right, so here's an example where we have what I'll call flat vars. So we have a function foo, and for those of you that are new players to the game, foo, bar, baz, you're going to see these. It just means it doesn't matter what the function does. What it means is don't pay attention to this thing. Pay attention to the high-level concept. So let's say that we have var answer inside of foo and var random inside of bar. The question is, what is the scope of these variables? And the answer is that answer is available anywhere inside of foo. It is not available inside of bar. It is not available outside of foo at all. Same thing. Random, available inside of bar, anywhere inside of bar, not available outside of bar at all. All right, now let's take a look at a nested example. Similar thing, except now I've moved this function bar inside of the function foo. So where is the scope? Well, answer is going to be scoped to anywhere inside of foo and anywhere inside of bar. And then random is scoped anywhere inside of bar. So trick question number one is, what's the scope of awkward here? So here on line 10, here's awkward. What is the scope of awkward? There's only one rule, which is that variables declared, the declaration of the variable is to the whole scope of the function. So awkward is available up here, over here. It is available anywhere. Now, it is specifically assigned on line 10, so if you were to use it somewhere that, how to explain this? Any function that it's used within, if it was used within bar, that's not a problem because it will actually get to line 10 before it gets down to wherever bar is called. But if we had used it, say, on line 3, we would kind of sort of get an error, but it wouldn't be the error that awkward doesn't exist. It would be something else. So that's the scope there. So when people try to make this sound complicated, they talk about hoisting, they talk about weird things. It's very, very simple. It's a little peculiar, but it's simple and it's consistent. Anywhere in the function, recursively, meaning as many functions as there are. If there's loops, if there's anything, it's only to the function and it's anywhere in the function, the whole function recursively. Okay? So scope starts at the function declaration, and it's scoped to the whole function. As I said, recursively, we went over that. We beat that over the head with a hammer. Okay, so here, answer is available anywhere in foo, anywhere in bar, anywhere in baz. Random is not available in foo, but it is available anywhere in bar and anywhere in baz. Likewise, deep is available in baz, but not in bar or foo. So there we go. So trick question number 2, how many scopes are there here? All right. We have, let's just see what I say here. It's this scope. It's the whole function. There's only one scope, and it's the whole function. So I think that just to give this a little bit more context, because I don't know if I actually go back to the slide or not. So var silly, the reason that I'm calling this var silly is because it is silly to put a var inside of a for loop because the var is scoped to the function. It's silly to put a var inside of the for declaration because the variable is scoped to the for loop. So there's not a new silly for every single iteration of this loop. It's the same silly every time. All right, so there's one function, one scope. All var have whole scope function, whole function scope. All right, trick question number 3. What's the scope of no func? Now, this is something we didn't cover, but it's pretty simple. There is no scope. No function, no scope. Now, if a variable does not have scope, that means it is not contained. If it is not contained, then it is everywhere, and it is a global. So the rule is consistent, again, although unusual. So my conclusion about var is different, but not bad, because it is consistent and it's simple to understand, especially if you're a new programmer. If you're an experienced programmer, you expect all these things. You want all these different scopes. You want all these different rules because you're used to that. But if you're coming into JavaScript as a beginner, var is really simple. And if you're thinking about how to implement JavaScript as a language, var is really simple. So that's kind of the benefit to it. Now, const is tarded, and I will get to this. Number 1, the thing that I don't like about it, which is not the important thing, this is just what's stupid, is the appropriation of the word const. So this is what a const should look like. And so what we have here is const, capital letters, pi equals, and then some constant, something that will never change throughout the universe, time, and history. And so this is a quote from the Rust for Rustaceans book, which it describes how const normally behaves in most languages. And so I thought that was apt. The const keyword declares the following item as a constant. Constant items can be completely computed at compile time. This is important for what a constant has been for all of the history of computer science. And any code that refers to them is replaced with the constant's computed value during compilation. A constant has no memory or storage associated with it. It is not a place. You can think of a constant as a convenient name for a particular value. Thank you, John Jingset. All right, so const means constant. Const can be computed at compile time. The value of a constant doesn't change. These are what make a constant. And conventionally, it also is going to have, it's going to be in all caps. So we use that as an indication to the reader. Anywhere in the program that you look at it, you can visually tell, oh, this is meant to be a constant. This value isn't changed, etc. So, but that's not how it is in ECMAScript. ECMAScript doesn't really obey any of those rules except for one, kind of, sort of, sometimes. So as you can see here, greeting, every time this function greet is called, greeting is going to be a different value. It is not constant in that sense. It is, in fact, a variable. And so if it can't be computed ahead of time, it is not a constant. If this were part of, say, a macro, then we could say, yeah, sure, it could be a constant, because it could be, if it was a macro that could be computed at compile time, and this was the syntax of the macro, sure, we could do that. But that's not the case. All right, here, this just defies all reason. Const items equals empty array, and then you can push onto the array. That is completely mutable. So can it be mutated at all? If so, it is absolutely certainly not a constant. And so people will say it's an immutable reference. And to that I say an immutable reference is no more a const than acne is a cancer. Okay? You don't go to the doctor and say, hey, I think I have a pimple, and the doctor freak out and say, oh, it's cancer. You know, you don't get to, I mean, people do this all the time, but const is a superlative in programming languages. It has a definitive meaning, and it's very extreme. And to just say, well, it's kind of sort of an immutable reference sometimes, it's not a constant. Anyway, so that's why I hate it. People say, but if I do it with an integer, it throws an error. It's an immutable reference, but it's not a constant. All right, so that's really not the important part. I spent too much time on it. That's just because of my emotional grr inside, right? But part B, what I'll call just moral cause, is that people have developed a religion around functional programming and immutability, And so it's a just moral cause to use constant because it's just and it's moral. And this is even worse because this just leads to bad programming, as we'll see. So this is a readable conditional assignment. We have greet, we have a var foo, and we say if there's a name, then foo. Oh, whoops, there's actually a typo in this. This should be a template string, but forgive me for that. So this foo is equal to this, otherwise foo is equal to that. And we could do this a couple different ways depending on how we want. I just wanted to make this super clear and super readable. There's no ambiguity as to what this function does. And then with const brain drain, this is the kind of crap that people write. Again, forgive the typo. I'll fix that and as soon as we're done with this. So if this is just not clear. First of all, const foo, it's obviously not a constant because it's completely conditional as to what it is. But because in JavaScript, consts don't behave in a sane way. So in other languages, you could have, let's say, an immutable reference, not necessarily a constant, because constant must be compilable at compile time, and that could include macros, like what Zig does. But let's say that this was supposed to be just an immutable reference. Well, normally with an immutable reference, you can declare the immutable reference on one line, and then you can assign it on another line. So this would work, say, for example, in Rust, we could do let foo, and then foo equals this, or foo equals that, and that's perfectly valid because foo is immutable, and you can assign to it once, and that's acceptable. Oh no, hold on. We just skipped a billion slides here. Let me see if I can get back there. Sorry about that. Okay. Okay. So, and ternary expressions in particular are the devil's playground. So anything that makes people feel like they have to use ternary expressions, and heaven forbid nested ternary expressions or ternary expressions with lots of ands and ors, this is just, it's bad code because it's not readable, and you're requesting that somebody do something that is ultimately to their detriment and your detriment and everybody else's detriment that has to deal with the code. Okay, anyway, moving on. Above all of that, this is kind of a weird thing to include in JavaScript because forgetting whether or not I want to change a variable is not typically a problem that I have. I don't know about you, but I suspect that it isn't. So it's kind of a weird, just kind of, blah. All right. Now, there is a particular case where we might forget whether or not we wanted to change a variable, and I'll get to that in just a minute. So now let's talk about let. Let is Schrodinger's var. So if you're familiar with Schrodinger's cat, the cat is dead and alive, and it just depends on when you look in the box, then you find out what the cat is at that moment, but the cat is both dead and alive. That's what let has become. So let is supposed to declare variables in block scope. So this doesn't make any sense, but this is valid JavaScript. And in particular, it's actually whole block scope. So just like there's whole function scope, we have our awkward here and our super awkward here. Super awkward is also actually declared up at line 8, even though we see it declared at line 12. So this is a little bit weird. So let doesn't even function in the way that you're kind of, it's not the sugar-coated fairy tale that you were told. And that mostly works, but it's only necessary for anti-patterns. For example, if you have really, really long functions or you have really, really long for loops. So that the types of things that let enables you to do are typically things that are code smells. And let also breaks switch, which, you know, and this is an example of how let will break switch. So this is why I called it Schrodinger's var, because just like we saw before, it still is scoped to the entire block, which has this thing called the temporal dead zone. Basically, you can get weird errors in your code because of that. And this is similar. This is kind of one of them. So in case foo, we might want to declare answer equals 42. And in case bar, we might want to declare answer equals 4. Well, this won't compile because you'll get an error, or this won't run at all because you'll get a runtime error saying that answer is already declared. Okay, well, easy enough. Let's fix that. So if we then say, all right, well, we'll just let answer here, and then we'll do answer equals here, since the first thing that we do is we do let answer, then answer should be available here, but it turns out that it isn't. So let is both declared. If you try to redeclare it, you get an error, but it is also not declared because if you try to use it, you get an error. So that's the primary offender. And the way that you get around this is that you can create extra scope inside of a case, and I'd recommend you leave the break on the outside because breaks kind of apply to a block. So I'm not quite sure what happens if you put the break inside. I just keep it on the outside to be safe. But this is, there's a workaround for it, but it's a weird thing to do, and it's not a problem that we had before. So it doesn't solve these situations very well. But let does allow you to write confusing and otherwise buggy code. So for example, here's our function confusing for let count equal. This is the canonical example that people give as to why we need let, because you might want to do a set timeout and a for loop, which I won't go into the correct JavaScript coding patterns in detail here, but this is not good JavaScript code. So yes, let allows you to do these things, and it allows you to write really long functions with variables put further down in the function, but it just, yeah. All right. So here's where I think there's some missed opportunities. Problems that I do have that let and const could have solved. Number one is shadowing. So let does not enable intentional shadowing. So this is what I mean by shadowing. Shadowing in other languages, such as Rust, have this, where you can declare a variable as a string. Say you need to get user input from an input field. So you can get that as a string, and you might want to call it answer because that's what it is. That you ask for an answer, they input the answer 42. There you go. And then you might want to declare answer again, but you want to declare it this time as an integer. So you have one answer declared as a string, and then you want to say basically, okay, let's forget that answer that's a string, and we're going to declare a new answer as an int so that we could parse the integer, and then we don't have to have an answer stir and an answer num. We can just have answer. And the reason this is important is because if you just assign to answer twice, let's say I don't have a let here, then what will happen is it will slow down the JavaScript optimizer, because the optimizer will say, hey, this is a string. And then it'll say, wait a minute, you didn't declare anything different, but now you're switching the type on me all of a sudden. It was a string, now it's an int. And so this actually basically causes the JavaScript optimizer to hit a speed bump and have to slow down. And so we want the optimizer to be able to know that when we're dealing with an integer, we're always dealing with an integer. And when we're dealing with a string, we're always dealing with a string. And we're not going to switch back and forth. And this is the sort of thing that could have been solved, but wasn't. And then also, here's another type of shadowing that you'd think would be allowed, because now we have two different scopes. We have a scope foo and we have a scope bar. But the problem, because of what we talked about before, where let is scoped to a whole block, not from the area where you declare it onwards, the answer here would actually be the undeclared answer from over here. So this would not be answer the string 42. This would actually be, consider this two separate statements as if you had let answer semicolon and then answer equals % answer. So this would actually throw an error because answer isn't available yet at the time that you're trying to parse it. So this is something that you could expect and would be useful, but it doesn't happen. And then const, even though it's an immutable reference and not actually constant, something that would make sense for it to do is to prevent unintentional shadowing, like this. So say, for example, the opposite case. I have a variable that I don't want to accidentally redeclare in the same scope. So I have a name up here and I have a name up here. It would have been nice if it's a constant, we shouldn't be able to redeclare it, right? But that's not the case. You can declare name in this scope, and then you can again declare name in this scope. And so you can't use const to protect yourself. And then, of course, try catch is still broken. Not that I think that this is something they reasonably could have fixed in the language with let or const, but a try catch has a specific meaning, and what it is that the stack will get rolled back and everything within the try will get undone. So if we throw an error inside of a try, which this one would execute all the time, we would expect that whatever happened above, so this line above where name equals foo, would get undone. So name would be unassigned. So name would go back to whatever its initial value and whatever its previous value was. So if we had name equals Bob up here, and then we did name equals foo and we threw an error, what we should expect is that now name would be equal to Bob, because try catch will undo whatever was done in the block of the try. However, nothing is undone, the stack is not unwound, and then you would still get foo, which is unexpected behavior if you come from any other language, and I think just kind of a bug in JavaScript. What do you do? Okay, so with all that said, this is my takeaway message. Var is the better of the three of them, because const and let fail to make ECMAScript like other languages. So if you're familiar with the way that const and let work in other languages, you're not going to get that in JavaScript. It doesn't fix JavaScript's bugs, as we've seen. It doesn't fix shadowing. It doesn't fix issues with declaring to the specific area where you intended to declare it. And it adds more bugs that didn't exist before, such as mutable constants and the temporal dead zone, issues with switch, etc. Therefore, bad idea. Now, you go and make your own conclusion. But that's all I've got to say. If you liked it, give it a like. If you'd like to have more content like this, sub and follow, click all the things. You know what to do. Now, for those of you that are watching in live, I didn't give a lot of interaction and opportunity to ask questions because I'm going through this presentation thing. I'd love to know how you like that format, but I'm going to stick around for a minute and just let you ask some questions and hit me up with whatever you got, and we can take a minute to talk about that, and then we'll have another stream after this one that's in my more traditional live format. Hey, easy. Thank you. I appreciate the compliment. Seeing no further questions, thanks for joining in. Again, give it a like if you want to, sub or follow or whatever it is. If you liked it, share with somebody that you like. If you didn't like it, share with somebody that you don't like. And remember, it is my birthday in about 6 months, almost to the day. So, like and sub for my birthday. Trying to hit 5,000 likes and 10 average Twitch followers. That's the goal. So I will catch you later. Adios.